Hi. So in the last video, I basically showed you a graphical way, basically using a table of values, to find the inverse. Let's do this now for actual functions and see how that works. So the basic strategy for finding the inverse of a function. So the basic strategy when you're given an equation is basically switch the x and y, right? We're switching the x and y because we're switching the inputs and the outputs. Switch x and y and then solve for y. The reason why you're solving for y is because now that you switch the inputs and outputs, you want to see things from the perspective of a different variable. So in other words, before when we were given the inputs, we wanted what the outputs were. Now, once we switch them, we want to solve for y because now that our outputs are now our inputs and our inputs are now our outputs, so we want to see things from the perspective of like basically the inputs. So let me show you what I mean. So I have an example here. So basically the example says find f inverse. So remember, the notation for an inverse is the f -1 superscript of f of x is equal to x squared minus 3. Okay? And what I'm going to do is I'm actually going to set a domain for this. Okay? I'm going to say this is x is greater or equal to 0. Okay? So what that means is let's actually just see how that would look graphically. Let's actually solve this graphically first, and then we'll do it numerically and then figure it out. So in other words, I have, say, a line there and a line there. And since this is x squared minus 3, what that means it sort of goes down, and we have a parabola that will face up. I'm going to use a different color. So normally, we'd probably just have minus 3 over there, and then we would draw it like that. Okay, we would draw it like that. But keep in mind, I've set a domain, and I've set this domain to be x is greater than 0. This is an arbitrary domain that I've set. I could have said x is greater than 1 or something, but I've just simply chosen x is greater than 0. So if it's x is greater than 0, I can only pick the stuff that's where x is greater than 0, and keep in mind that x is 0 right here, and the y value is -3, but the x value is 0. So what I'm going to do is I'm going to erase this whole part till about there. So this is what really the function looks like. Okay, basically what we did graphically was we just took some points, right? We took some points and we just sort of switched them. So let's find some coordinates here based on this equation. If I find some coordinates over here, let me just do that. If I find some coordinates here, if I have x and y, so one point is 0, -3, so 0, -3. If I plug in 1 over here, so 1 squared minus 3, so that's 1 minus 3, so if x is 1, y will be -2, because 1 minus 3 is -2. If x is 2, so in other words, I have 1 point here, I have another point here where this is -2, and that point is 1. It's a little too crammed. It's a little too crammed. So let me just erase that there, and let me just write 0 over there. So this x value is 1 for this coordinate. So for this coordinate right here, the x value is 1, the y value is -2. For this coordinate, the x value is 0, the y value is -3. Anyways, let's just continue with this. So if I have a value of 2, 2 squared minus 3, so it's 4 minus 3, that's 1. So that's going to be right there. So let's just find another point. So let's just say I have a value of 2 over here, and my coordinate is going to be 1. So I have these 3 coordinates, right? And now if I wanted to do the inverse, all I have to do, if I want to apply the inverse transformation, all I have to do is simply switch x and y, okay? X and y, and all I have to do is switch them, so it's -3, 0, -2, 1, and 1, 2, right? So let's plot these points. So -3, 0. So -3, 0 would be somewhere here, okay? So that's -3, 0. -2, 1 would be somewhere here, okay? So that because that point is -2, and then 1, 2 would be somewhere here. 1, 2 would be somewhere there. And if I connect these dots, basically it looks like that. So this green function, I've just basically plotted this value, and that's how I got these this inverse function up here. So if I plot this, this is the inverse function right here, okay, and this function right here is the original function, okay. So I've basically plotted both the function and the inverse on the same graph. Now, so we know what the equation of f of x is, which is x squared minus 3, where x is greater or equal to 0. Let's figure out what the inverse function is. So remember, the strategy is you simply switch the x and y and then solve for y. So let's do that. So where do we go? Go here. Okay, so let's try that. So we know that f of x is simply x squared minus 3, right? So in other words, so this is the original function, this f of x right here. So really, I'm just saying y is equal to x squared minus 3. I really haven't done anything so far. Now the first step is you have to switch the x and y if you want to find the inverse. So in order to switch the x, so all you literally have to do is just simply switch x for the y and y for the x, okay? Now we've basically switched our inputs and outputs. But now we still want to see things in terms of y. So what we're going to do is we're going to solve for y. So if we're going to solve for y, it's going to be x plus 3 is equal to y squared. And we can see that y squared is, I'll just rewrite it as x plus 3. And let's do this. Y is equal to the square root of x plus 3. Okay? So, and if you kind of look at this function right here, this itself looks like a square root function. And if we're doing x plus 3, what that means is it's a transformation. It's a transformation to the left by 3 units. And we see that over here. It's a transformation to the left here by 3 units. So that is the solution for the inverse. So all you have to do in order to find the inverse is switch x and y, right? And then solve for y. Okay? So let me give you another example. Let's do like another example. Let me just use white for example. So let's say f of x is equal to 2x plus 1. Okay? And I say find f inverse of x. What is it? Okay? So we just have to do the same thing as before. So first, we just write the original equation, which is y is equal to 2x plus 1. Then switch x and y. So x equals 2y plus 1. Okay? Then what you're going to do is just solve for y. So it becomes x minus 1 is equal to 2y. So y is equal to x minus 1 divided by 2. So therefore, the inverse function, f inverse, is equal to x minus 1 divided by 2. All right? So that is the basic strategy of how you find the inverse. In the next example, I'm going to go over a very important thing where we compare the original function and the inverse function and compare the domains and ranges and see what happens. All right? So stay tuned for the next video.